I'm going to solve another A-level physics question. A-level physics. Okay. A raindrop of mass m falls to the ground with its terminal speed, and the specific heat capacity of the water is C, and acceleration of free fall is G. Given that 25% of the energy is retained in the raindrop when it strikes the ground, what is the rise in temperature? So first I will explain the terms. For example, terminal speed. For example, when the raindrop falls, okay, from the certain height, okay. Now, as we know that the weight of the raindrop acts downward, and the air drag force that is acting on the upward side. Initially, the initial speed of this raindrop is, for example, 0, and when it drops, its speed going to increase. Will speed of the raindrop increases as speed of the object increases. As we know that the drag force acting on the object must also increase, because drag force is directly proportional to speed. As we know the from Stokes law, F is equal to 6 pi eta r v, where v is the speed. Okay, so it means when the speed increases, the drag force must also increases, because drag force is directly proportional to this speed. So as long as initially we know that the liquid droplet is falling down, so it means initially its weight is greater than drag force. That's why it falls downward. Okay, so as long as the speed increases, so drag force also increases. A stage way when at stage later on, when the weight of this equal becomes to equal to drag force, mean the drag force increasing until this drag force equal to the weight, then the speed no more increases, mean now the weight droplet falls at the constant speed, because the weight and drag force are equal in magnitude. So it means now the speed becomes fixed, speed becomes constant. So this speed is known as terminal speed. Okay, terminal speed. And so it is given that the droplet falls at the terminal speed, mean at the constant speed. Okay, now the specific heat capacity is the actually the heat required to raise the temperature of, as we know that heat required to raise temperature of 1 Kelvin of 1 gram of the mass, mean if we have a mass of 1 gram, so if we want to raise the temperature of 1 Kelvin, so how much heat is required? This heat is actually the specific heat, the specific heat capacity, that is represented by C. So as we know that, we know the equation for the specific heat capacity, that is equal to mc into del T, that is related to temperature, mean the heat required must be proportional to the temperature raise, and it also depends on the mass. If we have a greater mass, so it means the heat required must also be greater. If we temperature rise is more, so it means heat required is more. So in other words, so basic equation is Q is equal to mc into del T, where C is the constant of proportionality, that is the specific heat. So this is equation for the specific heat capacity, Q is equal to mc del T. And we know that when the water droplet is falling and before striking the ground, and after striking the ground, and before striking the ground, its energy, when it is given that energy, it retains the energy, that is the 25% of the initial kinetic energy, mean before striking the ground, its energy is kinetic energy is equal to half mv square. Kinetic energy is equal to half mv square. So when it strike, okay, so it's 25% of energy, this value half mv square is retained, that is converted into rise in temperature, means 75% energy is lost, so it only retains the 25% of energy, and that is converted into heat. Okay, that is converted into rise in temperature. So it means first we know the find the 25% of this kinetic energy. So 25% of this kinetic energy is equal to If we want to find the any percentage, so we just multiply and divide by the 100. Okay, 25% of this value is equal to 25 multiplied by this value divided by 100. So we just solve and we get 4 1 over 8. We get 1 over 8 mv square. Okay, now we can compare these two equations because this heat is also the form of energy. So heat is also a form of energy. So we can compare equation 1 and 2 and we can find the del T temperature. Comparing equation 1 and 2, so we get mc del T equal to 1 over 8 mv square. So we need to find the del T, rise in temperature. So mv square over 8 mc. So del T is equal to mv square over 8 mc. mv square over uh, m is cancelled. So we got v square over 8c. v square over 8c. So D option is the correct one, that is v square over 8c. I hope it is done. Thank you.